Now let's take a look at strategies to impute missing values. So assume that we don't want to delete those observations. We're not sure what type of missing values we have. Then we can choose to use some other values to replace missing values. So this is called imputation. There are two main strategies to replace missing values. One is to use machine learning models to predict missing values using other features. Right? A commonly used one is k nearest neighbors, KNN, k nearest neighbors. So KNN use k nearest observations according to some distance metric, usually Euclidean metric, to predict the missing value. So the underlying theory is that observations that are close to each other, for example, we have observations, two-dimensional data like this, right? And for example, this data point has a missing value in some feature, right? Then because these observations are very close to this data point, right? We can assume that their other feature values, the feature values are very similar. Okay, even the value that is missing should be similar to the neighbors in a small neighborhood. Right? So this is the logic of KNN. We would learn how to fit a KNN model in module 4, supervised learning. But for now, we just use it as an imputer. Scikit-Learn has this imputer, KNN imputer. It's very convenient to use. So let's first, again, generate some data. We use make blobs to generate 1,000 observations with 2 columns. Okay? And then we scale the data, okay, using standard scaler. I save it here, standardized features. Okay? And then we save the first column, first row value. We call it true value, right? And then replace it by a missing value. Right? So we create a data set with a missing value. Okay, when we change it to a missing value. Okay, and then let's try to use KNN imputer to impute this missing value and see what happens. Okay. And we first instantiate the imputer. Right? You need to specify how many neighbors will be used to do prediction for the missing value. And the weights by default is uniform. That means, so in this example, suppose this is the data point we want to impute value, and the neighbor is 5. Number of neighbors is 5. Then if weights equals uniform, then all of these 5 points have the same influence on the prediction of the missing value. Right? And later on, we can see other options. And then fit transform, let's see. So this is the true value, 0.873. Right? This is imputed value, 1.96. Right? So it's quite close. Right? It's quite close. We have tried our best. And notice that if we use KNN imputer, you always feed the entire features matrix into it. You see, no matter no matter there are missing values in a column or not, we always directly feed the entire matrix into it, because this KNN imputer will try to impute each missing value in each column with other columns, the rest of columns. For example, if you have a matrix like this, right, with a lot of columns, right, and you have a missing value here and a missing value here, And if you feed this entire matrix into the KN imputer, it will impute this value, this missing value in X1, using all of these columns, right? And at the same time, it will impute this value using the rest of the features as well at the same time. Right? So it will try the best to impute your missing values, right, in any column. And as I said, by default, it will use all of the 5 neighbors in the same way, treat them equivalently. But you also have the option to let weights be distance. Then observations that are closer to the data point you want to impute value will have higher weight on the predicted value. Okay? So if your data is not very regular, for example, some data points are very far away, somehow far away, you want to use this argument, weight equals distance. Okay? And for us, the result is slightly improved, 1.02. So previous one, we have 1.09. So it's, the error is smaller actually. Okay? And alternatively, we can use some column statistics to impute values. So if you use machine learning modeling, you are using other features to predict values in this particular column, right? Other features, right? But you can also choose to use column statistics in this particular column. Right? So the function is called simple imputer. Use a single value. For example, let's create a new data set. Not actually the same data set. Okay? Still, we replace the first value by a missing value. Right? And then we can instantiate the simple imputer using strategy equals mean, which means we will use the column mean to replace the missing value. Right? We fit and transform the features, and let's run this. Okay? So this is the true value. This is the imputed value. The performance is very good, very good. So apparently, that is because we use mixed blobs to create the data set, the feature matrix, and the data are very regular, basically normally distributed. So the mean is actually a very good representation of the entire column. Okay? So let's calculate the mean of the original features matrix with the missing value. Is -6, exactly the same with the imputed value that we use to replace the missing value. So indeed, it used the mean of the non-missing values in the column. If you think the data is skewed, you can choose to use other strategies. For example, you can use median. Okay? If the data is skewed, then median is a better measure of center, right? And then we can create a new imputer and fit transform, do the imputation. And apparently for our toy data set, the performance of median imputer is worse than the mean imputer. Yeah, again, it's because the data is very normal. And we can check the median of the non-missing values, exact the same with the one that we used to impute the value. Next topic is imputing missing class values. In last lecture, we learned how to impute numeric values, right? So now let's take a look at a categorical data if there is any missing value. Okay? So one solution is to use the statistic to replace the missing values. For categorical data, the most intuitive one is the most frequent value in the column, or the mode. right? The most frequent value, which because for categorical variables, the mode has the most frequency, and it is supposed to be the most representative value among all of the values. So it makes sense, right? So this is kind of like a simple imputing method. And still, import the simple imputer function from the impute submodule of Scikit-Learn. And then let's create a toy data set so the first 4 rows do not have any missing values. And the last 2 rows has a missing value in each row. So see, have a missing value in each row. And then we stack them together. I vertically stack them together, call it X complete. The reason that we create them separately is because later on, we will use machine learning model, basically k nearest neighbors to impute the values. In that case, in the training part, in the fitting part, we can only feed a complete matrices into it. Okay, so it's not the KNN imputer anymore. Okay, it's a classifier. Okay? It's a real classifier. Okay? So we'll see a little later. But anyway, don't be surprised. You might be curious why we created them separately. Okay? There is a reason. Okay? So anyway, this is a complete data frame, okay? Feature matrix. Then instantiate the imputer. Right? Simple imputer strategy is most frequent, which means the mode. For numeric variables, we use median or mean, right? But for categorical variable, we use most frequent. I just call it imputer and fit transform our data set. And then you see that 1 is used to impute the missing values. That is because you see among these 4 values, right, 1 is the mode. 1 has the biggest frequency. 3, 1, and 0, 1, 0. So definitely we should use 1 to impute the missing value. So this is the simple imputer. Alternatively, we can use machine learning models to predict missing values in any column in the data frame, right? So instead of using KNN imputer, because the KNN imputer last time, the imputer that we learned last time is designed for numeric values only, numeric data only. It cannot be used to predict labels, right, or categorical variables. So we will actually use the machine learning model, like k neighbors classifier, so to do prediction. So to do it, we first need to instantiate the classifier, called a function. Oh, by the way, the function is from the neighbors submodule in Scikit-Learn. And we instantiate it. So we use 3 neighbors this time. So k is equal to 3. And weight is distance. And then we can fit the model. Again, as I said, most machine learning models, actually all machine learning models, cannot take missing values directly. Forget about KNN imputer. Okay, so that is not a machine learning model. It is a imputer that uses a machine learning model. Okay, so that one can accept missing values because it is used to do that, to impute values, right? But a regular machine learning model in Python will not accept missing values. So that's why when we create the features matrix, we separate them, right? One part does not have missing values. The second part has missing values. Okay. So notice that we only feed the first matrix to it. Right? And also when you call a machine learning model, you have to separate the features matrix and the target column. So the first argument is the X matrix. The second argument is the Y vector. Right, so notice that when we create them, they are together. Right, so this is the, okay, actually, this is the column with missing value, which is the first column. Remember, the first column has missing values in the second part. Right? So we treat it as a target vector. Right? And then train the model, and then we can do prediction for the part with missing values, right? And pay attention, we just feed the part without missing value, which is treated as a features matrix. And then we can save the result in imputed values, right? Same result. If we use k and n, we get the same result, right? 1 and 1. Okay? So the k neighbors classifier can help us to predict categorical values, okay, or factor values. So it's 1, 1. And then we can do some more data manipulation. So we first make the imputed value as a vertical vector, and then horizontally stack it with the part without missing values. Right? So this is the kind of the second part without missing values with imputed values. Okay? Then furthermore, we can vertically stack the part without missing value and the part with missing value together. So this will be the complete feature matrix after the imputation. Okay? So it requires some work, apparently, because there is no k and n imputer for categorical variables in Python.